As background, we want to address these from a user perspective. For example, as a general contractor, I have specific needs of my model. I want to know about the information I can gather from my data set. Here are examples from DOTs that show the kinds of data that we're able to receive and process in the model. Uh, we know what the contractors need to learn from these models, and the folks who are presenting are going to show us how we can achieve our goals. Um, Ground rules, they know that they're not going to give marketing content. This is about helping us all understand what is possible given the tools that are available in the field. And we have very distinguished panel of presenters today. We're going to begin with Solibri. We have Jason and Ken. Then they'll hand it over to Dalux, where Ben and Juliana will give us some more examples. Finally, we'll move to Catenda with John and Jonathan. The order only represents reverse alphabetical order. There's no other intent in that. So, with that, I will pass it along to the Solibri team.
Thank you so much, Tony. And welcome, everyone. Thank you for joining us today. I'm Jason Rachel. I'm the country manager for Solibri in the Americas, and I'm joined by my colleague, Ken Good, who is a customer success manager for us and will be running through the product demonstration. Next slide, Ken. If you're not familiar with Solibri, we are a part of the Nemetschek Group. The Nemetschek Group is a global AEC software company made up of many well-known brands that you see here, like Bluebeam, Allplan, and others. And for more than 25 years, Solibri has been widely recognized as the best-in-class model checking and QA solution for our industry. Our solutions help design and construction teams lower their risk, reduce rework, and resolve issues before anything gets built in the field. And we do this through a rules-based approach to quality assurance. We do it through openBIM standards, which allows you to plug Solibri into your existing workflows. And we're going to demonstrate that here today. And so I will now hand over to Ken to demonstrate how this can be applied to transportation projects.
Cool. Thanks, Jason. So today I've got Solibri here, and we're going to just do a real high-level overview of the key stages that Solibri can be used in your workflow to help improve model quality and coordination in your projects. So this is pretty much Solibri as it comes out the box. I mentioned workflow, so we're going to go through these main stages here and give you a taster of where Solibri can be used at each stage. And we generally follow the same pattern. So we always start by opening and combining. We support the openBIM workflow here. So we start with IFC models that we bring together to create our what we call a federated model. We then spend a bit of time organizing that model to clear up some of the noise or maybe focus the checks on key areas. And then the main part of what we're looking at is checking. And again, in terms of openBIM support, we support the IDS information delivery standards at this stage as well. I'll skip over extract just now because first run through a project, we need to get rid of the obvious errors. And when I say obvious, the ones that are very difficult to see but usually cause the biggest problems. And it's little things tucked away, it's copies of things, it's obvious when it's pointed out to you. So we'll go through that stage and then we'll come back to this. But the final stage is once we've identified any problems and issues, we need to grab those together, report them, and send them off to the various parties to get fixed so that we can start a flow of information. So as we issue things then with BCF, another openBIM standard, that will go back to the authoring tool, the models will be updated, and then we start with revision B, revision C, whatever it is, coming back in and then running through the process. So as we get rid of those early problems, we can then start to look at information takeoff, which is where we can extract data from the model in whatever format. So I'm going to go through, prepared this little presentation here. We'll go through, show you what we're going to look at, and I'll go through these key stages to show you how all this comes together within our models. So first thing is, this is the building we're looking at. I have it right now as a canvas. I say bridge, sorry. I'm using it as a canvas for this information here, but you can see it is actually a real life bridge. It's the PennDOT example that you saw a second ago in the intro PowerPoint. But you can see how it comes together. We can view it from different angles, turn things on and off, look through it. But what you can see is it is a complete bridge model. The one thing I would say about it is it's a little bit too complete. So usually when we are with Solibri trying to find things, we like to find lots of errors, but actually this is a pretty tidy model. So I've had to fake some of the results to make it more obvious. So first stage is this open and combine, and this effectively means we're just bringing together the different models. So for this, I've got the two different ends of the bridge. We've got the barrier section, we've got the pier, and then we've got the structure. And that comes together to create what we call our federated model, which is where it's all combined. And in here, all I've actually done is tweaked some of the content slightly just to change some of the colors and make it more obvious. And I've added a section, but you can see we can cut sections through, and you can see it's a live model that we can play around with to whatever we need. So moving on from that, the next stage in the process is organizing, and that literally means just tidying up, decluttering, removing noise, whatever it happens to be. So in this case, I've changed the view of it just so I've got transparency and I'm able to see the content of the model. But it might be that we want to actually just focus on one location. We can obviously hide all of this ghosted content behind as well, but it means we can switch from side to side or end to end. We can go and start to familiarize ourselves by looking at what's down here. We have various annotation tools that allow us to stamp things. If I just leave the mouse for a second, I've got this little pop-up will come up to give me some information and feedback of what is underneath the mouse. And then we've got the usual sort of annotation tools that allow us to go and slap on dimensions and look at volumes and lengths, widths, whatever it happens to be. But the main part of what we're looking at is to go and check the model and find errors. We want to get rid of the errors because the sooner we can do that, the cheaper it is to fix in the long run. So I've got a load of these. You'll be pleased to hear I'm not going to go through all of them because we only have 15 minutes. But I'm going for these first ones that I talk about, these obvious ones, which actually, if you were to see this in the full context of what was in here, we're looking at half a dozen pieces of rebar in probably a million other pieces of rebar. So finding problems is quite tricky to do it visually. But what we've done here is identify that we have duplicates. So there's a duplicate assembly, and then there's individual duplicate items in there as well. And all it means is that these items have been placed more than once, identical copies sitting on top of each other. So if you were to try and look for them, then you're going to be looking at something like this. So you can't even see the rebar. You might make this transparent and start to have a look through it. I'd have to go further, but it's quite tricky. So we need to find those. In terms of quality, there's other simple things that we want to go and look for. So one of the little sort of cheesy names that we have here is that Celibri's spell checker for BIM. We don't actually spell check, but we go and look against other criteria. So in this case, all these lovely red things, which I think there's 212 of them, these are items that are fairly critical items to the structure of the bridge, but there is actually a spelling mistake in their definition. So there is an R missing from superstructure. And critically, that means if we're filtering and pushing lists of acceptable items into a further check, with that spelling mistake, they might not go into the check. So then we miss things and we have further issues. So we need to find those. Other bits and pieces here, there's lots of little things like these are almost false positives, but they're reassuring that it has found them. Rebar is sunken into concrete, and it sees this as a much smaller item inside a much larger item, which typically is a problem if you're working in a building and there's a light fitting, but the smoke detector's in the same area. For a rebar, we can actually process that and deal with it in a different way, which we'll come on and show you in a second. So let's actually, let's grab this one here, and then what we'll do is we'll jump to the results and we'll look at how we actually go about processing some of these. So this is now a different part of the interface. This is a typical part where people go through, run what we call our rule sets to identify the problems, and then once we've identified them, go and deal with them. So I've got a couple of different ones here, but this hidden component matrix is just it's a clash detection matrix that we've set up, but it's actually only looking for hidden items. So all of these items here, all these reinforcing bars are hidden inside all of these other component types. We can double click and that'll change the view in the background there, and you'll see it will jump around and find where these different components happen to be. With that, what I can then do is when I move on to my main clash detection matrix, when I go and configure that, bearing in mind that there's lots of issues in here, I can configure this so that I ignore all those reinforcing bar components, because I know that they're sunken into concrete. I know they're going to cause lots of issues that are not actually real, so we can deal with them. Our clash detection matrix, what it does is sets up, it reads all the components within the model. You can configure it in different ways, but what it allows us to do is ensure that we hit every single pair of items. So every single beam to beam, bearing to beam, bearing to bearing, all the way through the list here. So we don't have to think about how that's doing that. It always creates the match, it doesn't miss anything, and it doesn't double up. But when we do get issues like these ones here, where I know there are known things that I want to avoid, we can tell it to ignore these items. I can tell it to prioritize other items with the red category, so that will flag anything as high priority. I've got low, moderate. And the other thing as well you'll see is I've got some are H, some are G. These are just the different tolerance settings. So I've got 3 different settings here, and it's just a case of, as I switch, that reapplies a different criteria. So we're trying to simplify that process as much as possible. Moving on to some of the more specific checks for the DOT, we've got some basic things here, like we're just checking the width of the route itself. Again, I've set this up to fail. There's a few different ways to do that, but then there's other sort of sense checks where we're picking up the fact that these pile components don't actually touch anything, or these ones touch, but they only touch by 3.5%. So we're checking the tolerance, the gap between items, to make sure there is adequate coverage. In a similar way, we can check things like walls. So these walls don't touch anything above. But in this case, because we're looking at a bridge, these walls don't touch anything above. In a traditional building, walls generally stack on top of each other as they step up through a building. So that doesn't happen here, but we have the ability with this filter, exactly the same rule, which hasn't actually run. Apologies, we'll run that one. And this time, the only thing it identifies is this temporary structure, because there is nothing holding it up. There's nothing around it. So that's a simple fix. That's not actually an issue. It's temporary. I physically removed it from the filter to make sure it would show me something, to give you something to look at here. Then get a bunch of data checks. So here we're looking at readiness. So what we've got is a bunch of items that are supposed to have a definition. So this pen.pay item description, it doesn't exist. So if it doesn't exist, we can't compare it, we can't check it. Similar for material, similar again for the quantity inside the general properties. We can then start to look at the data accuracy. So in terms of data, we're checking, does it exist? Does it have content? Is the content valid? Is the content part of an agreed list? Or we can even go down and start to look at syntax. So syntax is picking up things like, we have a load of rebar here, which should be E60. But in fact, all of these components here have got a value of, I'm going to have to go and find it. If we go back here, the actual value is 60 rather than E60. So again, as a filter, that means things can get missed. Making sure we don't have brackets, location item. So for the quantity, this should be part of an actual list, and it has the wrong value. So this is where it's actually starting to find some of the items that are the superstructure rather than superstructure, where it's missing the R, which is actually this one here. Oh no, it's not that one, it's a different one. But this is another one that I had to set up to fail. This model is actually a really good model. So what I've said is that bar number 5 is not acceptable in this list. So there's a whole list of what should be here. And I've told it that number 5 is not acceptable. So it's able to go and find all of these items for me. Final type of checks, we can actually do geometric checks from data because it's quicker and easier to compare values than it is to go measure something. So again, I've set this up to fail, but what we're looking at is an actual value. The bridge should be less than 25 feet wide, but it's actually, in this part of it here, it's 33 and a third. So we can do comparisons that way. Final part then is just IDS. So again, supporting openBIM. We can read an IDS file directly into the software. This will pick it up. This is a big IDS sample file that comes as part of the system here. And it's having a little bit of a think because it's got a lot to go and look at. But we have our own IDS editor. We can use that to bring in and do what's what. We can view them this way. But the other thing we can actually do when that finishes, if I go and grab this here, wrong one, sorry, a different screen. If I grab this, we can actually grab an IDS file and literally just drag and drop it straight into the system. And what that does is then separate out all the individual checks. So an early stage of a project, you might have this is what the agreed checking is going to be. But at an early stage, if we don't have content, we can start to select and then we can disable parts of it. So we have lots of choice there for what we can do. But let me just move on because I'm conscious of the time here. So that's having a look at the checking. For the extraction stage, we can start to pull out bits of data like this, but actually we drive it from this area called information takeoff. And this is where I can just do a takeoff. So I'm looking at rebar properties. Let's look at the entire model so you can actually see what it's doing. And then we can actually pick out and start to interrogate any parts in here that we want to look at in further detail. If I look at which one was it? Deck properties, not that one. Location for approach, there we go. If I take this one off, we can actually start to grab these items, and if there's extra fields that I want to bring in here, we can drill down into all of the properties. So this is location. Let's just take deck. If there's a particular part here that I want to include in the table, we can just drag and drop and bring that into the list. And this is where I'll probably find it's either blank or I've used it elsewhere. Oh, fantastic. I picked the one item that only has one little piece of text, but hopefully you get the idea. We can extract various data for different parts of the model as we require. So that's almost the final stage. The last bit is where we communicate this. So what I've done here is pull out some of these high-level issues. I want to make sure these get reported. We can either report them through physical files, so we can create BCF files and physically transmit them. We can send PDFs or RTFs if anybody's old school and remembers an RTF file, but they're fairly basic, simple documents. But the preferred method, I suppose, for paper is we go to Excel, we create a template. Again, if I switch screens, sorry, too many screens. So on this one, that's helpful. These are same Excel sheets or reports that have been pushed out where we can actually push them to Excel. We can give it branding, fonts, logos, colors, corporate branding. We can apply conditional formatting, add formula, whatever we need to do to create a really detailed, appropriate report from the system there. The only other thing we can do, the other thing we can do is rather than transmit documents manually, we can push to the cloud. So I can actually connect here to a CDE and pick up these items that already exist within the cloud, and I can select and import issues that I've identified here to then push them to the cloud and push them out to the wider team. So that is a pretty rapid run through of Solibri and what we can actually do. If you want to follow, but if you have any questions, you can get in touch with us through this, or you can find contact details on solibri.com. But thanks for your time for that brief run through. I'll hand over to Ben and Juliana from Dalux to continue the presentation.
Thank you very much, Ken and Jason. I'm Ben, here with Juliana. We represent the Dalux US team based in Chicago. Dalux is cloud software that helps improve collaboration in the design and construction phases. And we have a purpose-built module for infrastructure projects that we'll demonstrate today. Dalux was founded 20 years ago in Copenhagen, Denmark. We're widely known and utilized across Europe, particularly for our superior product and exceptional customer service. And we've recently expanded to the US to serve customers locally here. Our infrafield module is purpose-built for the construction phase of infrastructure jobs. And here's an overview of our features within the standard module, and then a pro version of the module that we also have. And now on to Juliana to start the live demonstration.
Juliana, could we ask you to unmute your microphone?
Thank you very much. All
Um,
right. Can everybody see my screen?
Got it.
yeah, looks
Okay, cool.
good.
Okay, great. Yeah, so today we're going to show you all three models, starting with the Iowa DOT. I'm going to show PennDOT's SR6. I'm going to show our generic demo model to show some advanced features that we wanted to mention as well, and then hand it over to Ben on the iPad. He'll show PennDOT's Rearick Road. All right, so Iowa, we've decided to show you this in our free BIM viewer. And just how do you get models into Dalux with IFC and drawings? You will just upload them from your desktop and they come right into Dalux. In this case, we didn't have any drawings. For the purpose of the demo, I added an auto drawing where I just put in an elevation and Dalux will automatically cut that for you. One other note is one person uploads the model into Dalux and you can add unlimited users to be able to view these. On the browser, we have a desktop app and then the mobile app for iPads or Android phones and tablets. I wanted to briefly also show that we have imperial and metric features and then also various languages. All right, yes, so here's the model. You can measure, you're able to use the position marker for the coordinates. We have a 3D laser for you to use. We have point to point, which snaps to various points. And then we also have a 2D cut where you can bring that in and you can slide if you wanted to take a look in there. To view the metadata for any of the BIM objects, you can click on the object, and over here, on any metadata that comes in from the IFC model will be here. So you can review that, you can copy, you can filter. So if, for example, the IFC columns, I want to see all of those, so they will pop up. You're able to save filters. You can save them for yourself, or you can save them for your team. And here's an example of another saved filter that I have. Here's this auto drawing that came in. And on drawings, we also have measure features. So you can do the laser again. You can do the point to point, which will snap. And then you can also do an area. You can view 3D objects on the drawing. So this was my saved filter again, or you can pick which 3D objects that you want to see. And then you can open to 3D. And our split view really helps with navigating around the 3D model. You know, you can zoom around, but you can also pick which part that you want to see and move around on the drawing there. Let's make a comment. So we have these comment workflows. I can click on the object if I want, select comment, and now I can mark this up. there's different statuses. I can send it to who is responsible, put in the title, deadline, and what I need them to check. Once this is sent, you get email notification. So that person will receive this email, and then they can open up the comment and look at it in 3D, look at the screenshot, and then write the message, change the status. And then you can coordinate and look at all of the different statuses of all of your comments here. And then you can create import from BCF, and we also have the BCF Live Connector URL. So these comments are all BCF. We have Revit and Navisworks plugins. If you had those plugins, the comments would show up in there too, but I know we're working with IFC today. On to PennDOT. Here, I just wanted to show you, this is our paid infrastructure platform. So the other one was our free version. So on comments here, there's a lot more capabilities. You could have custom communication channels. You can create all of the statuses that you want, and you can have submittals. We have a quantity takeoff here, different file areas, files, published, shared, ISO 19650 compliant. We have a design module as well, where you can compare different versions of the model. And then we have model validation too for clash detection, clearance checks, and then also property checks. So if you wanted to make sure that IFC pile was in all of the pile BIM objects, you can kind of set up all of the metadata checks that you would like. And then quantities, I didn't show you the quantity takeoff in box, but this is a little bit similar, where you're able to filter on different BIM objects to see the quantities here. So this is all of the reinforcing bars. And then I made another filter for just the specific bar. And you're able to save those filters, but also export them to Excel so you can manipulate the data further. Onto my generic demo to show you, here's where we have structures, which could be in this case a station or a bridge, and areas, so you can also add the roads around it. We have drawings. If you want to bring in some drawings, they will automatically be placed on the geolocated reference. We have GIS data. If you bring that in, you can customize the symbols. You can actually create your own GIS data in Dalux, and all of the metadata is here too. You'll be able to bring in your alignments. You can click on the alignment to show the section cuts. And you're able to move back and forth from any of the stations, and you can create the distance in the settings. But then here you're also able to measure. We have a bookmark feature. That way, if you want to save certain measurements and views, you're able to save them in here, but you can also copy the link if you want to send it to someone else in the project. And then point clouds. I opened it up in another screen just since we didn't have too much time to show everything, but yeah, here are the point clouds. You can measure from these to the BIM model, and you can also compare it to the 3D BIM model if you want. We also have 360 photos. So if you have a camera, you can bring in photos and compare different dates and compare it to the 3D model if you would like as well. Here is quantities. We have terrain quantities, which it's a feature where it compares two surfaces and calculates the difference between them in the volumes. So you can see them here too. I created these surfaces from a terrain and then also a design surface that we have. And then you can do this with alignments as well. So this will compare a surface to the alignment and displays the height difference along the alignment as well. The last thing that I wanted to show before handing it over to Ben is some of our construction management options. We have tasks, and tasks are registrations. They're usually punch lists, site observations, and RFIs. You can send these to people in what we have is like work packages and user groups. And you have all of the station versus offset, the coordinates for where you created this task. And it'll bring you right there in the model if you click on that. We have inspection plans, and this is a list of predefined points that needs to be inspected. And if you wanted to, you can have these associated with 3D objects or object groups, and you'll get an overview of the progress. And also checklists. Checklists are digital forms. You will select the location that you're creating the checklist, and you'll also be able to see the coordinates and the station versus offset for where that checklist was created. And with that said, I will pass it off to Ben, where he will show you the mobile device.
Thank you very much, Juliana. Let me, as quickly as possible, flip over on the iPad. All right, folks. So we now have our Dalux mobile app, which is meant to be simple, intuitive user interface designed for field use by non-BIM, non-CAD users who are typically out in the field. And again, it's cloud-based, it's mobile-friendly, and works on both Apple and Android devices. So I'm on an iPad here, works just as well on a phone or an Android tablet. And if in certain cases there is no internet connectivity on site, we do also have an offline mode to go along with it. So I'm on our home screen here. What I'm going to do first is click into the locations, and what we basically have is a map view of the project. So we're now looking at PennDOT's Rarick Road. And this blue outline is kind of outlining the 3D model in geospace. So it was placed based on the eastings and northings coordinates. And using the drop down at the bottom right, we can choose different map types or map layers. So we have a couple defaults, but we can also integrate with a WMTS map service if you have other layers you like to use. And if you look in the top right corner, I'm not actually going to press it, but the little location type icon that looks like a triangle, that's GPS location. So because I'm not standing in Pennsylvania right now, it's not going to make sense on the map. But the concept is a user standing on site would be able to geolocate themselves on the project, particularly if it were a lengthy highway, but certainly a bridge works just as well. And accuracy right now is based on the GPS chip in the phone or tablet device. We're working on integration with a third-party piece of hardware that's going to end up giving 1 centimeter accuracy if the user has that hardware attached to their device. So using that, it essentially drops a pin or a dot where that user is located. And then from there, they can choose to create some kind of registration. So in this case, it's an RFI that was set up with custom fields, but could just as easily be an issue, a defect. It could be, as Juliana showed, a point in an inspection plan that needs to be completed. And then if a user wanted to view the actual 3D model from the mobile app, they could click on the model, press 3D, and now, I know you can't really see how I'm navigating this, but I'm basically pinching in and out and kind of navigating around with my finger. So now that we have the model side by side with the map, or if there were drawings on this project, we could see those too. You can interact with these IFC objects just the same as on the desktop version. So perhaps I want to hide this object because I want to see down into the next layer of the bridge and help me visualize that a little better. Perhaps I want to measure something. So we have a few of the measure capabilities, point-to-point, laser, and 3-axis, and this kind of snaps to the nearby objects like so. And then you can even do cuts on the mobile app. So this is, all meant to help improve visualization while on site without having to haul, heavy equipment out there. And then finally, last thing is here's where the offline mode would be located. And then we also have this capability to scan QR codes on both drawings to verify the latest version of a printed drawing is the actual latest version on the Dalux Cloud project. And we also have the ability to locate a user. If QR codes were posted on site, they could scan that code and then jump right to that location in the model and in the drawings. And with that, that concludes the Dalux demo. Passing it over to the Catenda folks.
Okay. Hi, this is Jonathan Whitney. John, you want to put up our slide there? So I want to, first of all, thank you for the opportunity today, because this is a great opportunity, and it's a chance to demonstrate just a few of Catenda's capabilities. And what the biggest thing about Catenda that I would just want to leave you with is that we're all about being open. It's not just the motto of the open way. We're talking about being open as a philosophy, as a company. And Catenda's based in Oslo, Norway, and they've been around since really 2009. And we do cross paths with Dalux frequently, and there's a lot of similarity between some of the offerings. But the possibility to be open and sharing is what drives us. So I think John is the presentation there. I think today the number one thing is that being open also means 100% cloud-based, and we want as many participants as can participate to be included. So with that, I'll turn it over to my colleague, John Lipp, who I've worked with over the last 20 years for most of that time. So you're muted, John.
And unfortunately, I had to jump out of the presentation for a second. So yeah, so I'm going to pick it up from here and demonstrate the capabilities of the platform most relevant to bridge projects. We'll jump right into project workflow, looking at some the use of topics for issue tracking and resolution, and we'll finalize the presentation with how people can leverage the platform across the project lifecycle with the example of a QTO for an estimator. So I'll dive right into the application. When you first log in, you're presented the projects panel here. These are all tiled across here. If you're invited to, or if you create your own project, they'll be listed. This is the project I created for this presentation for the...
John, we're not seeing your screen.
There you go.
It wasn't showing us before?
No. So maybe you want to go back to the
I'm sorry.
page.
Yeah, so when you first log into Catenda, you'll see this projects that you've been invited to or ones that you've created yourself. They'll be tiled across here. We're going to be opening up this openBIM in action project that was created for the session. And then you'll land on the dashboard. And this gives you basically the ability to track how things are going. You'll get a count of how many issues are open. You'll have issues, which were called topics in Catenda. They're assigned to you. So basically, you'll have eyes on things that you might need to take action on before you actually dive into your project. Here you can see some other models that have been recently been open, and I've kind of combined them and partitioned them out into the different 3 bridges that we have here. And also you'll notice on the left here, these are basically the functionalities of Catenda. The three pillars you could say are documents, models, and topics. So everything you bring in is a document. You'll have review, mark up your documents, version control. If those documents are IFCs, you can then federate those as models to then view in the integrated 2D, 3D viewer. And then to communicate issues or any problems you have, you can use topics, essentially. You can use Clash, QTO, any type of issue or communication you want to convey to your stakeholders. I'll go ahead and open up the documents panel here. And being that it's a CDE common data environment, it looks familiar to some of the others you might have seen. Everything is a document, as I said. So these are the file formats that you can load into Catenda. And even has a viewer for some of these. Like, for instance, I can open up the presentation and view it in Catenda. And being that it's for CDE and review, you can actually mark up and annotate, documents and send them off as topics to others to review themselves. But going back out to the main folder, I've organized it by the different bridges, different projects. And if I click on, for instance, Iowa dot, you can see this is an IFC. I've already validated it, actually loaded it in, processed it into Catenda, so it has this little icon that shows it's a model, which means I can then view it in the 2D, 3D environment, right? And I've actually done this. Normally, you wouldn't have all of the projects all combined into one, but these are all the IFC models that I've loaded and processed. In order to dig in and organize things, I've created some metadata, some labels. You can see across here labels. These are SR6, Rearick Road. So you can easily find what you need. You can just click on labels. One of the things I noticed was that these basically have the same file naming conventions, so that they'll have B12, for instance. I can, if on the fly, real quickly, type that in, hit enter, and then it'll just prune out everything besides the SR6 I want to focus on first. So now that I have those listed, I can click on this checkbox here, click 3D, and it'll automatically load my my viewing for the 3D. And everything's basically toggle on, toggle off. If you have to add more real estate, you can now close this. You can have multiple monitors, you can have multiple tabs. It's a browser-based platform. But now that I have this listed, I can then turn on something else, like, for instance, the model tree. Being that it's IFC, IFC has a nice structure to it. This is the IFC model loaded here. I can expand out, look at the actual structure of this. So if I click on superstructure, you'll see the top portion here. I can dig down into the substructure to this abutment, and then go down into the foundation and whatnot, look at individual piles and footings. If you click on an individual component in the 3D view, you can then turn on, for instance, this model info view, and then expand out here to see the inspect tab. And this is where all the attribute, all the property information is listed using IFC. So you'll see identification properties, you'll see your dimensional pile lengths and your materials. It's also probably familiar from other review softwares. You can position your camera. If you want to, you can use your ASDF keys to walk around, or use this little tool here. You have other abilities to change to whatever the perspective you want. You can do a top-down view, have a plan-looking view. There's also, as I said, a 2D integration where you can add sheets, for instance, plan views. And then as you move around, it'll actually show you on the map. Unfortunately, there weren't any of those sheets included with the IFC set. But you can change it to orthographic if you're more familiar with that type of viewing. And you can dig into the model to see what's inside. So for instance, you can right-click on something, click the make translucent, and then you can see the actual rebar that's inside of this right here. Or you can actually use sectioning. It's called clipping planes. You create a clipping plane. I'll click to the direction of the path of travel along this bridge, and then you can see the internals of it. And actually, the path of travel is interesting. There's alignment functionality within Catenda. So for instance, if there were alignments, IFC 4.3 actually has alignment, IFC alignment. So you could actually clip the clipping plane to follow the path of travel, for instance, of a highway or a bridge. Unfortunately, those weren't included in the file set to show. But with that, I will then move to a different model And there's different ways you can get around. So instead of going back to the models tab, I'll just click bookmarks. And I will go now to the Iowa US 59, and just by clicking this, and essentially it's a viewpoint. It'll just then take me to that location. Again, normally your project will have multiple projects in different locations, so it's just now isolated those models and changed the camera position using that bookmark. And from here, I'll turn on my measure tools. And just like a tape measure, you basically pick one spot and drag and click it to another spot. But there's some automated dimensioning. You see that it actually color codes and added some other dimensions like the height and the length of this footing, which is nice. So anything will save you time to click. So if you don't need them, you can always turn them off, turn on what you need. Change it to fractional inches, any of the actual units you need to use. Another thing I thought was really sharp for automated dimensioning was the laser measure. So if you click on a surface of a component like this footing, it'll then give you the dimensioning to another edge. But what you can do is then turn off these other listings here. And what it does is it essentially segments out these dimensions across the width of this bridge. I can then click on this arrow here, and what it does is just adds more dimensions across, so you can see everything's uniformly distanced apart, and the size of these footings are all the same. You can then actually even turn on these segments, and then you'll get a total running count from one end of the footing to the other side of the bridge, and see what that length is. So again, pretty sharp measurement capabilities. And that's essentially the reviewing capabilities of the software. And I can just dig right into kind of the workflow of issue management. And like some of the others, I didn't find many issues with the bridge per se, but so I had to create some. So if I turn off my measure tools, I can click on something. And if you might have noticed, if you click on a component, it'll show you how many issues are open or not open. And if I click on this footing here, what I did was I basically just created an issue for testing purposes. And what issues are called topics in Catenda. So if I open up this topics, it's going to give me a listing of all the topics that are currently open. I can filter by what's open or not. So now it's listing closed topics. But the point is, if I click on this this open here, it will then just filter out only the topics that I've attached to this component. So essentially, you're attaching notes or whatever you need to your model assets objects. And you can also see what's assigned to you if you look in the info view. And what's also nice is that whenever you're inside the model, if you need to get to this location, you go to your topic, you click this little play button, and it'll take you right there. And it's actually attached. You can see if I click on this show selected objects, is now selecting that object. And the process of creating a topic is pretty straightforward. I had some problems finding anything wrong with the model, except for maybe this, what I thought at first was the pipe. Again, you can turn things off that you don't need to have for more real estate. But if I click on this, you can see it's a cable carrier segment. And I see this kind of running at an angle outside of the out of this barrier. What I can actually do is use this select intersecting. And what this does is kind of like a mini clash detection. It's going to run through and see everything that this cable carrier segment's running into. And once it finishes, it'll just show in green. I didn't know at the time that it actually spans across the entire barrier length of the bridge. And I can then, again, make translucent, see that it's actually going through here. So if I want to have eyes on it for my team to give me some information if this is a problem, again, I'll just turn everything on. I'll zoom into where the issue is located. I will click on the component here, and then I'll go to my topics again. And from here, I then can click Add Topic, New Topic. And what I have here, again, now I'm doing my coordination. I don't have to have the view of the 3D open anymore. From here, I can add a title. Let's say, is this aligned? Or I can just basically say a cable alignment as the issue. And then I can assign a responsible party to look at this. And what I'll do is I'll just assign this to Jonathan, or I can actually assign it to a team that he's on, which is Catenda. So I'll click this. And this is, here's the BCF. It's a embrace openBIM workflow. So this is actually using BIM collaboration format. So you'll have statuses that, for instance, you can have it be active or closed based off of whether or not it's approved after you fix it. Or if it's not an issue altogether, Jonathan can just reject it and say it's fine for it to be coming out that way. And types, you can set different types, customize it to whatever you want. This is fitting that it's a clash, but again, you can create your own. And these are topic boards. Again, these are generic issues topic boards, but I could create a topic board, for instance, for meetings, or I could do it for specifically for clashes if there's a whole listing of clashes, that is. Yeah, and add comments and set due dates, whatever you need. So after I click submit, what'll happen is John's going to be then notified. Again, I can click on this. It'll take me directly in the model to where it's located. But more importantly is how are people going to be notified of issues? And in this notifications tab here under settings, you can customize this to however you personally feel. If you want to have anytime a new topic is created in the project, you can be notified. Only those assigned to you. We don't suggest ever using email for transferring files. You should keep everything in Catenda is the idea. But if you do need to, be notified, you certainly can have notifications through email, or we integrate with Slack and Microsoft Teams. And with that, I'll then jump right into the estimator's hat and look at some QTO. And for that, again, I'll use my bookmark, and I'll go to our PennDOT road model. And I can turn this off. And what I'll focus on are here's some quantities I want to look at from rebar. So here's all the rebar showing here, and it's the module is actually called object query. And I think the reason for the query is that to kind of showcase the power of the filtering and the querying, not just of the properties you want to get out, but how are you going to pinpoint to the actual assets? Because basically it's asset management and reporting on the quantities of what you actually want to the subsets of the components you actually want to look at. So here's a listing of all the quantities, the default listings. I can go in here and say whatever I really feel I need to look at. I don't really need long name. I don't need object type, and predefined type maybe not needed. And so here are all the components that are in this Ruric road model. But I want to turn off everything, for instance, besides my reinforcing bar. So you can think of these as all properties. I'm going to look at my entities. I'll do only the reinforcing bars, add this as a filter. And now it's pruned it down. Actually, I should probably filter this only by what's visible in the view. There we go. And then I can add my my entities reinforcing bar. And so I have 3,494. If I want to prune it down even further, I can actually look from a size standpoint. So for instance, I know that there's a size I want to look at property. So for there, I can turn on bar size. I can click equals. And it's just going to list only the bar size that is 10 or any values that are actually there to pick from. I can turn that on.
We have a couple of questions from the attendees, and we'd like to be able to give them an opportunity to voice those over. Do you have like 30 seconds of last licks?
Oh yeah, this is it. So after that, you then isolate the components in the 3D view, and then if you need to get the quantities, you can go to our QTO tab here, and you can export those out to Excel or CSV or whatever you need to import into your platform. So, and that's it. So I'll turn it back to Building Spartan.